Dear audience, we're Team 8. Here's our presentation. Our motivation is to build a face recognition model for ASD people. One of the most evidence feature of their social impairment involves deficient communication via emotional expressions. Here is our problem test. We want to get deeper understanding of the CN model and categorize each face based on the class weight or something. And here's our data set looks like. The first column consists of 6 degrees, and the second column consists of the purpose of the role. The third column consists the images. And here is our baseline model.
This is our baseline model's result. We can see our test accuracy for baseline model is 0.53, around 0.54. And here is the confusion matrix result from our baseline model. We can see like for the 0, our prediction is 0.39, and for 1, we don't know why it somehow all of the data got dropped, and so it's all become 0. And it's all around, like everything else is all around the 0.5. Next.
Okay, and after some thoughts, then we used a more advanced CNN model, which contains both batch normalization and dropout methods to seek a better test accuracy. We first added a batch normalization layer after each convolutional layer, and with a dropout rate with 0.5 in the end of the at the end of the batch normalization layer. And the overall test accuracy for the batch normalization model becomes 0.53, which is relatively smaller than the baseline model, and it may due to the dropout rate. And here's we actually use more epoch to train our final model based on our training data sets. And here is the confusion matrix results from our batch normalization final model. The relatively high accuracy of happy and surprise might be caused by the imbalanced data input, and the prediction of disgust could perform better if we had more input data to train from. And we also compared the both of the models. By the comparison, we could easily see that for emotions like angry, disgust, fear, and surprise, which is labeled as 0, 1, 2, and 5, the final model performs relatively better than the baseline model, especially in the disgust. As we see previously, where the disgust, the true positive prediction of disgust is 0.0, which is there's no prediction of disgust at all. But now we can see there's a 0.21 precision score for the prediction of disgust. Where the baseline model cannot predict the disgust, the final model definitely performs much better. And here, the same conclusion is verified by the classification results containing the precision score, recall score, and F1 score, where the above is the baseline model score and the below is the final model score. And the same conclusion applies when we talk about the previous page as well. And that's all of our presentation. Thank you so much for listening.